All right, because of our technical difficulties this morning, I had to rush through this lesson, so let me go back and explain a few things for you. Remember, we're talking about natural logarithms, right? We're talking about natural logarithms. Basically, the concept is the value of e. All right, so let's get right to it. I don't want to take a lot of your time. But a key concept here in this last section is raising a log or natural log to its base will equal the exponent. Raising a log or natural log to its base will equal the exponent. So in the left situation, what we have is a base 10 with a log x exponent. The 10 and the log x undo each other, or the 10 and the log undo each other, the common log, and the result is x. And the same thing with e. E with the exponent of natural log x, the e and the natural log undo each other, and the result is x. Okay, so that's the key concept. And we did a couple problems here, and we worked our way through. The first one had just one single solution. The second was quadratic. And so we came up with two solutions, and we had to check to make sure that both solutions were viable. And what had happened was, if we substitute in the -3 for the variable, we'll end up trying to take the natural log of a negative number. So that's what I was trying to explain over here. So if we change the form there of the natural log of -3, right, you get e to what power equals -3. And the answer is there is no solution, because e to 0 is 1, e to 1 is 2.71828, e to a negative number is 1 over e, but that's still a positive value, and you can't get to a negative, and therefore that value is extraneous. All right, so that was the idea. Okay, let's do the other couple examples here. Excuse me. So on C, again, I need to get to the log, and this is a log instead of a natural log. And I need to get to the log. So again, I need to move this 4. This 4 needs to move. I can, excuse me, really do a couple things with it. The easiest thing is to just put it on the other side. Okay, that's the easiest thing. Divide both sides by 4. At this point, then, what I want to do is I want to take a 10 base. So now base 10 here, base 10 here. Remember, this is all an exponent, right? So where do you end up with? 10 to the 3.2 divided by 4 exponent equals 5n. And now we're one step away from getting to our variable, right? We can just divide both sides by 5. So you need to make sure that you can punch this into your calculator. You can use your 10 to the x button, or you can do your y to the x button. Either way will get you there. Excuse me, 10 to the x button or your y to the x button. Either way you're going to get there. So let's see how this thing turns out. Okay, and I got 1.2619. 1.2619. Did I divide by 5? I'm not sure. All right, let me run this one more time. 3.2 divided by 4. All right, 10 to the x of that power equals, yeah, I did. Okay, and then we divide that answer by 5. Yeah, 1.2619. 1.2619 is the solution to that. Okay? All right, you look at D, and the issue with D is the plus sign here. Because if you try to do a base 10, you have to do it to a whole side. And if you try to do that, that's a mess. So again, whenever you do, okay, base 10 and make the whole left side the exponent, the whole right side the exponent, that doesn't work. So that's not going to be good there. So really what we need to do is we need to get to a single logarithm. So we need to get to a single logarithm, and we just need to decide how we're going to approach that. Well, I'm looking at a couple things. So I know there's a lot involved in a problem like this, but if you break it down, it's not so bad. So here's the thought process. So first off, I know I got to do something before I take a 10 base to both sides. Here's my variable. And look, I can do the product law and put those two together, right? But now I'm putting my variable together. I'm not so sure I want to do that, though I can. It's fine. It'll work. But in my mind, why don't I just move the positive log 3 to the other side and make it negative log 3? Okay? Now, by the way, this is just a number. This is your common log button, 4.1, minus your common log button, 3. That's just a number. So that's not a problem. Now I'm ready to do base 10 on both sides. So on the left, the base 10 and the log undo each other, and you're left with 2n. And on the right, you still have 10, and the exponent looks difficult, but it's really not. Common log of 4.1 minus the common log of 3. That's no big deal. Now, by the way, you don't want to try to get rid of just one of these logs. That wouldn't be true, because again, it's base 10 of the whole side. Okay, but that's doable. And again, how would we move the 2? We're just going to divide both sides by 2, right? So that's where you end up. So let me punch this out and see where we go. Okay, hopefully as you punch that out, you end up with n equals 0.6833, really bar over the 3, that keeps going forever. 0.6833, right? So what seemingly looks quite difficult in reality isn't that bad if we understand a few concepts. So let me go back again and again understand that I wanted to get to my variable. I could have used the product law to put those two on the left together as one, or I could just move the log. You might say, well, on the right-hand side, they're not together as one. Yeah, I know, but that's just a number, and I can work with that. By the way, I could have made them one as well using the quotient law, but there was no need. Okay, the green box here could have been made 1, right? The log of 4.1 divided by 3. But again, there was no need to do that because they're just a number. But I could have. All right, I don't want to confuse you. Let's go on to E. All right, so E, we've got this situation. We're in pretty good shape. Now this 2 is in the way, right here. And if I put it on the other side, it's in the way again. So the only way to get rid of this 2 is to use the power law. It's got to go with the 6. That was the only way on that one. We had to do that. Now again, we want to do a base 7 of both sides, right? Because that's what our base is. And if these didn't match, it would be a little bit more difficult, but we could still do it. So base 7, both sides. So remember, base 7, log 7 undo each other. And the left side is 12n. And the right side, again, base 7, log base 7 undo each other. And the right side is 6 squared, or 36, right? Now we're just going to move the 12, and we're done. All right, n equals 3. And that's that one. N is 3. And you can play around with it, punch it out, and you'll see that indeed that is the case. N is 3. Okay? All right. Be careful. Those are a little tricky, but they really are the key to what we were trying to learn concerning these logarithmic equations. If you can do them, you can do anything. And so that's what you want to work on. All right. Let me get rid of this box here that I did earlier. And my pen is lagging, but that's okay. Okay. So formula, continuous compounding. A equals PE to the RT. All right, don't forget the P is the initial amount. The R is the interest rate, always in decimal form in any problem. And of course, the T is the time. All right, so here's our problem. Our problem says, find the time it takes. So we're looking for a time. for $3,000 to grow to $7,500 if the rate is 8.5% compounded continuously. Okay, so in this situation, we want to end up at what amount? $7,500. So that's the A value, right? In the way this formula is listed. Could have been f of x as well, f of t, whatever. The initial amount was $3,000. And now we have E, and we can put in the value for the rate. The rate is 8%, 8.5%. So 0.085, right, is 8.5%. And then our variable, which is time, which is what we're looking for. Okay, we can do this problem. We want to isolate the E. So I want to move that 3,000. You're just going to divide both sides by 3,000. That's all you need to do to isolate that E. Okay, now I want to take the natural log of the left and the natural log of the right. Because again, natural logs and E's undo each other. So here's where we're at. Natural log of, and so again, what you have is, I'll use a parentheses because it's clear what you're doing. Natural log of 7,500 divided by 3,000. That's just the button on your calculator. And then on the right, we have 0.085 t. And you can see now it's easy to get the t, right? Just going to divide both sides by 0.085. So go ahead and see if you can run that on your calculator and get the correct answer. You might want to pause this if you don't want to hear the answer right now. Spoiler alert, spoiler alert. All right, and if all is right with the world and you punched it correctly, then you should end up at 10.8. And what was our time in? This is continuous compounding, so time would be in years. 10.8 years to over double your money. That's not bad. Double and a half, really. You end up $7,500. That's great. Okay, so that's the idea of solving. We're able to solve. Remember, logarithms allow you to solve for the exponent. That's when you use them, when we're trying to solve for an exponent 10.8 years. Okay, I hope that's a help to you. Hope you enjoy your weekend. This does conclude the chapter. Schedule-wise, we're looking at a review on Monday, quiz on Tuesday, test on Wednesday. All right, have a great weekend.